Oh hey, didn't see you there. Why don't you come with us on a computational fluids journey?
In this journey, we will experience the flow simulation in SOLIDWORKS 2016. Flow simulation can provide a pretty good analysis on a computational fluid dynamic level and give you pretty accurate results and generic results of kind of flow trajectories and forces. And that's what we're going to go through today. So the first thing you want to do is go to the Flow Simulation tab. If you don't have this tab, you just haven't added it in. And go to the add-ins, click Flow Simulation. So from here you want to click on the wizard. You want to make a unique name as to your simulation to avoid renaming the same name and overriding older projects. Click Next. We're going to want to use SI units. For this project we're going to use an external flow. You can do an internal flow, you would have to make a wind tunnel. And click Exclude Internal Space and Cavities Without Flow Conditions. This just allows for less errors. And click Next. We're going to use air. This wind turbine likes to use air. Click Next. For this we'll just use default settings. Now for this screen here in particular, we're going to use negative 15 meters per second in the negative X direction, and that's because we have our Z pointing out this way and we want our flow to come here. As a regular wind turbine speed is between 12 and 15, so if you keep that number that should be okay. Right now SOLIDWORKS is just creating our fluid volume. This only takes a few seconds, and it's because we have a very large turbine. We actually have a full scale turbine, and if you wanted you could cut that into a scaled one. But anyways, we will now click on the domain. You can see it here. So we'll minimize the space to cut down computational time. Again, just click here and you can simply just drag the domain to desired size. And we're just going to go a little bit above the tower and click anywhere. Next you want to set up the goals. So these are the results that you want to see out of your simulation. For us, we want to see velocity, we want to see our turbulent intensity, just our average value, forces on the X and Y, and our torques. Torques will actually show us if the turbines will want to rotate. The blades, sorry, will rotate. And click OK. Now for global mesh, we just want to bring it up maybe from a 3 to 4. The larger you go, the more exponential time it will take to compute. So 4 will do for this simulation. Click OK. Now the important thing here is inserting local meshes. What local meshes do for us on this turbine is our blades geometry is very sophisticated, and we need a smaller mesh to mimic this geometry. So we're going to click on our revolve 1 here. So we did it all as one part to simplify. And we'll bring the refining cells to a 6. And we'll just leave all the rest on a default setting and click OK. So now you're ready to run the simulation. So just simply go up here and click Run. And click Run. So while SOLIDWORKS is doing this, we can show you some of the things here. SOLIDWORKS will pop up with a solution. So you want to click that, and it just shows you right now it's actually preparing the mesh and initializing the mesh on the wind turbine. So it takes a few minutes or seconds here to create that mesh, especially because we did those local mesh points. So while it's doing that, we'll just show you what happens if you don't do these mesh points. You'll get a result that looks like this. And so your flow trajectory is really not doing anything around the blades. It's staying at a steady speed, and that's because it doesn't know what to do when it hits these blades. It has no effect. So here's just a zoomed up version of what we just saw. So around the nasal, it knows that it will actually slow down and have some disturbance around the nose and the nasal. But we really want to see the characteristics around these parts. So that's why we do a local mesh. And what a local mesh does is here, we just save these images. So this is a large mesh, and here we have a lot finer mesh. And this local mesh now really defines the geometry of our blade so that the flow can be affected appropriately. And then now we'll just skip back to here to SolidWorks, bring up our solution. Now SolidWorks is doing all of its iterations, and here in this graph you can see that it's taking some time to converge, and as it would, since our meshes now are a lot more fine. So now we can see that it has finished all its calculations. In the green boxes here you can determine how many iterations it took for each one of our goals, and the lines down here are actual convergent lines, and we can go into those later and actually see separate by separate. So now we have some post-processing work to do. First thing we're going to want to see is a flow trajectory of velocity, so we will insert a new one. Under pipes we want to change this to lines, and we will click velocity here. Ours is already selected. So for the number of lines we're going to do 400. We're not going to go too crazy, and now you have to click the part bodies that you would like. If you're doing an assembly, you need to click the parts, and we'll click all three because we want to see all three here, and click OK. So now this gives us a pretty good result of our blades. Now we actually see that we have wind effect around these blades, and if you really zoom in you can see that on one side we actually have an acceleration of flow, and on the other we have a deceleration. So that makes pretty good sense for an airfoil. Zoom up here too on our nasal and nose cup. We can see the type of flows and eddies. Really nice visualization effect. The other thing you want to do, or could possibly want to see, is some of the goals. So we will insert see all show, and this gives us a table of our force results and our torques. So what you really want to do is important is this negative z direction torque is our torque in the clockwise direction of where our blades would be going, and it's a very large torque. This is a full scale wind turbine, so these are going to be very large numbers. You want your torque in the Y to be a lot less, so that would make sense. And you can see that we do have some bending in the Z direction, Y and X. Mostly your Z and X. Y, you don't have much bending going up and down, which is good. So then you can do some deflection calculations later if you wanted to. And now we're just going to see here these convergent plots that we were talking about. You can see that they're all converging at a good solution. Some roughness on the turbulence intensity. And yes, great. So there you have it. That is a tutorial for a flow simulation around a wind turbine.